Top 25 SDET interview questions and answers. Software Development Engineer and Test, SDET. Roles combine strong programming skills with deep knowledge of testing methodologies. SDETs are responsible for designing automated test frameworks, improving test coverage, and ensuring software quality throughout the development lifecycle. Preparing for an SDET interview requires understanding both development and testing concepts. Below are 25 commonly asked SDET interview questions with clear explanations to help candidates understand key concepts and confidently prepare for technical interviews. 1. What is an SDET? A software development engineer and test, SDET, is a professional who combines software development and testing skills to ensure high-quality software products. Unlike traditional testers who focus mainly on manual testing, SDETs write automated tests, build testing frameworks, and integrate testing into the development process. They collaborate closely with developers to identify bugs early and improve software reliability. SDETs often work with programming languages such as Java, Python, or C# and use automation tools like Selenium, Cypress, or Playwright. Their goal is to create efficient, scalable testing solutions that maintain software quality while supporting fast development cycles in Agile and DevOps environments. 2. What is the difference between SDET and QA? The main difference between an SDET and a traditional QA engineer lies in their technical responsibilities and focus. QA engineers typically concentrate on manual testing, writing test cases, and verifying whether software meets requirements. In contrast, SDETs have strong programming skills and focus on building automated testing frameworks and tools. They design scalable automation systems and often contribute to the product code itself. SDETs also work closely with development teams to improve testability and performance. While both roles aim to ensure software quality, SDETs are more involved in development practices, automation strategy, and continuous integration processes. 3. What are the key responsibilities of an SDET? An SDET is responsible for ensuring software quality through automation and technical testing strategies. Their responsibilities include designing and maintaining automated test frameworks, writing test scripts, executing automated and manual tests, and identifying defects early in the development cycle. SDETs also collaborate with developers to improve code quality and testability. They participate in code reviews, develop performance and security tests, and integrate tests into CI/CD pipelines. Additionally, they analyze test results, debug failures, and improve testing processes. By combining development and testing skills, SDETs help teams deliver reliable software products efficiently and maintain high-quality standards throughout the software lifecycle. 4. What is test automation? Test automation is the process of using software tools and scripts to execute test cases automatically without manual intervention. It helps verify that applications function correctly and consistently across different scenarios. Automation is especially useful for repetitive tasks, such as regression testing, performance testing, and large-scale test execution. Automated tests can run faster and more reliably than manual tests, improving efficiency and accuracy. SDETs typically write scripts using programming languages like Java or Python and use frameworks such as Selenium or TestNG. Test automation also integrates with CI/CD pipelines to ensure that code changes are continuously tested during development. 5. What is the difference between manual testing and automation testing? Manual testing involves human testers executing test cases step by step without the help of automation tools. Testers observe the software behavior and report any issues they encounter. Automation testing, on the other hand, uses scripts and testing tools to run tests automatically. Automation is faster, more consistent, and suitable for repetitive tasks like regression testing. Manual testing is useful for exploratory, usability, and ad hoc testing where human observation is important. In practice, both methods complement each other. SDETs focus heavily on automation but still understand manual testing principles to ensure comprehensive testing coverage and improved product quality. 6. What is a test framework? A test framework is a structured set of guidelines, libraries, and tools used to create and manage automated tests efficiently. It provides a standard way to organize test scripts, manage test data, execute tests, and generate reports. Frameworks improve code, reusability, maintainability, and scalability in automation projects. Common types include data-driven frameworks, keyword-driven frameworks, hybrid frameworks, and behavior-driven development frameworks. SDETs design and maintain these frameworks to simplify testing processes and support large automation suites. Popular frameworks include Selenium with TestNG, JUnit, Cucumber, and Cypress frameworks used for modern web application testing environments. 7. What is Selenium? Selenium is a widely used open-source automation tool designed for testing web applications. It allows testers and developers to automate browser actions such as clicking buttons, entering text, and verifying page content. Selenium supports multiple programming languages, including Java, Python, C#, and JavaScript. It also works with different browsers like Chrome, Firefox, Edge, and Safari. Selenium consists of several components, including Selenium WebDriver, Selenium IDE, and Selenium Grid. SDETs commonly use Selenium WebDriver to create automated test scripts and Selenium Grid to run tests in parallel across multiple machines, improving efficiency and reducing overall testing time. 8. What is CI/CD in testing? CI/CD stands for Continuous Integration and Continuous Delivery or Continuous Deployment. It is a development practice that automates the process of building, testing, and deploying software. In CI/CD pipelines, code changes are automatically integrated into a shared repository and tested frequently. Automated tests run whenever new code is pushed, ensuring that issues are detected early. SDETs play a key role in integrating automated tests into CI/CD pipelines using tools like Jenkins, GitHub Actions, GitLab CI, or Azure DevOps. This approach improves software quality, accelerates release cycles, and ensures that applications remain stable during frequent updates. 9. What is a test case? A test case is a set of conditions, inputs, and expected results used to verify whether a software application behaves as intended. It provides detailed steps that testers follow to validate specific features or functionalities. A well-written test case includes a test case ID, description, preconditions, test steps, expected results, and actual results. Test cases help maintain consistency and ensure complete coverage of requirements. SDETs often convert manual test cases into automated scripts to improve efficiency. By maintaining well-documented test cases, teams can track testing progress, detect defects effectively, and ensure that applications meet both functional and business requirements. 10. What is regression testing? Regression testing is the process of verifying that previously developed and tested software still works correctly after code changes or updates. When developers add new features or fix bugs, these changes may unintentionally affect existing functionality. Regression testing ensures that the application continues to function as expected. Automation is commonly used for regression testing because it involves running the same tests repeatedly. SDETs create automated regression test suites that run during CI/CD pipelines. This practice helps teams quickly detect unexpected issues, maintain software stability, and ensure that new updates do not break previously working features in the application. 11. What is unit testing? Unit testing is a software testing method where individual components or units of code are tested independently to verify their correctness. Developers typically write unit tests during the development phase to ensure that each function or method works as expected. These tests are fast, automated, and executed frequently during development. Popular unit testing frameworks include JUnit, NUnit, and PyTest. SDETs often review and extend unit tests to improve coverage and reliability. By identifying issues early in the development cycle, unit testing helps reduce debugging time, improves code quality, and ensures that each module behaves correctly before integration with other components. 12. What is API testing? API testing focuses on verifying the functionality, reliability, performance, and security of application programming interfaces. Instead of testing the user interface, API testing validates communication between software components. Testers check whether APIs return correct responses, handle errors properly, and process data accurately. Tools such as Postman, Rest Assured, and SoapUI are commonly used for API testing. SDETs automate API tests to ensure faster feedback during development cycles. Since APIs form the backbone of modern applications, especially microservices architectures, API testing is critical for maintaining system stability and ensuring seamless integration between different services and external systems. 13. What is the Page Object Model? Page Object Model, POM, is a design pattern used in test automation to improve code organization and maintainability. In this approach, each web page of an application is represented by a separate class containing elements and methods related to that page. Test scripts interact with these page classes rather than directly with web elements. This separation reduces code duplication and makes test scripts easier to maintain when UI changes occur. SDETs commonly use POM with Selenium to create scalable automation frameworks. By centralizing page interactions, the Page Object Model simplifies debugging, improves readability, and ensures cleaner and more reusable automation code. 14. What is test coverage? Test coverage is a metric used to measure how much of the application code or functionality is tested by automated or manual tests. It helps determine whether the testing process adequately verifies the system. Test coverage can include code coverage, requirement coverage, and branch coverage. High coverage generally indicates that more parts of the application are tested, reducing the risk of undetected defects. However, coverage alone does not guarantee quality if tests are poorly designed. SDETs use coverage tools to analyze which parts of the code are tested and identify gaps where additional tests are required to ensure comprehensive validation. 15. What is a bug or defect? A bug, also known as a defect, is an error or flaw in a software application that causes it to behave unexpectedly or produce incorrect results. Bugs can occur due to coding mistakes, design flaws, or misunderstandings of requirements. When testers identify a bug, they document it in a defect tracking system with details such as steps to reproduce, severity, priority, and screenshots. SDETs often use tools like Jira or Bugzilla for bug tracking. Identifying and resolving defects quickly helps improve software reliability and user experience. Effective bug reporting ensures developers understand issues clearly and can fix them efficiently. 16. What is smoke testing? Smoke testing is a preliminary testing process that verifies whether the basic functionalities of an application are working correctly after a new build. It is usually performed before detailed testing begins. The purpose of smoke testing is to confirm that the software build is stable enough for further testing. If smoke tests fail, the build is rejected and returned to developers for fixes. Smoke testing often includes checking core features such as login, navigation, or critical workflows. SDETs frequently automate smoke tests so they can run quickly in CI/CD pipelines and immediately identify major issues in new software builds. 17. What is sanity testing? Sanity testing is a focused type of testing performed after receiving a new build that includes minor bug fixes or updates. The purpose is to verify that the specific functionality affected by recent changes works correctly. Unlike regression testing, sanity testing is narrow in scope and concentrates only on relevant modules. It helps testers quickly determine whether the bug fix has resolved the issue without introducing new problems. SDETs may automate sanity tests for frequently updated modules. This testing approach saves time by avoiding unnecessary full regression testing while ensuring that recent changes behave as expected. 18. What is performance testing? Performance testing evaluates how a software application behaves under different workloads and conditions. It measures factors such as response time, scalability, stability, and resource usage. The goal is to ensure that the application performs well when multiple users access it simultaneously. Performance testing includes load testing, stress testing, and endurance testing. Tools like JMeter, Gatling, and LoadRunner are commonly used for this purpose. SDETs design performance tests to simulate real-world usage scenarios. By analyzing performance metrics, teams can identify bottlenecks, optimize system resources, and ensure that the application maintains reliable performance even during high traffic. 19. What is a test plan? A test plan is a detailed document that outlines the testing strategy, scope, objectives, resources, schedule, and approach for a software testing project. It serves as a blueprint that guides the testing process and ensures all stakeholders understand the testing goals. A test plan typically includes test objectives, testing environments, tools, responsibilities, risk assessment, and reporting methods. SDETs contribute to test plans by defining automation strategies and integration with development pipelines. Having a well-structured test plan ensures organized testing activities, improves team coordination, and helps deliver high-quality software within project timelines. 20. What is a test suite? A test suite is a collection of related test cases grouped together to test a specific feature or functionality of an application. Test suites help organize and manage multiple test cases efficiently. They can be executed together during testing cycles to verify different aspects of the software. In automation frameworks, test suites often run sequentially or in parallel. SDETs design test suites to cover critical workflows, regression scenarios, and edge cases. By organizing tests into suites, teams can easily manage large testing projects, track results effectively, and ensure comprehensive coverage of application functionality during automated or manual testing processes. 21. What is BDD? Behavior-driven development, BDD, is a software development approach that encourages collaboration between developers, testers, and business stakeholders. It focuses on defining software behavior using simple, human-readable language. BDD uses scenarios written in formats such as Gherkin with keywords like given, when, and then. Tools such as Cucumber, SpecFlow, and Behave support BDD testing. SDETs often implement automated tests based on these scenarios to ensure software behaves according to business requirements. BDD improves communication among team members and ensures that technical implementation aligns closely with user expectations and business goals. 22. What is TDD? Test-driven development, TDD, is a development approach where tests are written before the actual code. Developers first create a test that defines the desired functionality. Then they write code to make the test pass, followed by refactoring the code for improvement. This cycle is known as red-green refactor. TDD encourages writing small, testable units of code and helps prevent defects early in development. SDETs support TDD by reviewing test cases, improving coverage, and ensuring testing practices are followed consistently. TDD results in more reliable code, better design, and improved maintainability across software projects. 23. What is Selenium WebDriver? Selenium WebDriver is a key component of the Selenium framework used for automating browser interactions. It provides a programming interface that allows testers to write scripts controlling web browsers directly. WebDriver communicates with browsers using specific drivers like Chrome Driver or Gecko Driver. Unlike Selenium IDE, WebDriver supports advanced automation and integrates easily with programming languages such as Java, Python, and C#. SDETs use Selenium WebDriver to simulate user actions, validate web elements, and perform end-to-end testing of web applications. Its flexibility and cross-browser compatibility make it one of the most popular tools in test automation. 24. What is parallel testing? Parallel testing is the process of executing multiple test cases simultaneously on different machines, browsers, or environments. This approach significantly reduces the total time required to run large test suites. Parallel testing is particularly useful in automation frameworks where hundreds or thousands of tests need to be executed regularly. Tools such as Selenium Grid, TestNG, and cloud platforms like BrowserStack support parallel execution. SDETs configure automation frameworks to run tests in parallel for faster feedback during development. By speeding up testing cycles, parallel testing helps teams deliver software updates more quickly without compromising quality. 25. What skills are required to become an SDET? To become a successful SDET, candidates need a combination of programming, testing, and problem-solving skills. Strong knowledge of programming languages such as Java, Python, or C# is essential. Understanding software testing concepts, automation frameworks, and tools like Selenium, Cypress, or Playwright is also important. SDETs should be familiar with CI/CD tools, version control systems like Git, and test management platforms. Knowledge of APIs, databases, and performance testing tools is valuable as well. In addition to technical abilities, SDETs must have analytical thinking, attention to detail, and effective communication skills to collaborate with developers and ensure high software quality. Preparing for an SDET interview requires both strong technical knowledge and practical experience in automation and software testing practices. Understanding these common interview questions can help candidates demonstrate their expertise in testing strategies, development processes, and automation tools. By mastering these concepts and practicing real-world scenarios, aspiring SDETs can confidently showcase their skills and increase their chances of securing a rewarding role in software quality engineering.